In question number 7, the point P x comma y is moving along the curve y equals to x square minus 10 upon 3x to the power 3 upon 2 plus 5x in such a way that the rate of change of y is constant. We have to find the values of x at the points at which the rate of change of x is equal to half the rate of change of y. Now, when we're talking about the rate of change of x and the rate of change of y, so we know that the formula is dy by dt is equals to dy by dx multiplied by dx by dt. Now, in this question, it says that the rate of change of x is equal to half the rate of change of y. So we can write it as that dy by dt is basically twice the rate of dx by dt. So in place of dy by dt, we can write 2 into dx by dt is equals to dy by dx multiplied by dx by dt. Now dx by dt will cancel out. So as dx by dt will cancel out, so dy by dx will be equals to 2. So now we can find an expression for dy dx and put it equals to 2. So the equation of the curve is y is equals to x squared minus 10 upon 3, x to the power 3 upon 2 plus 5x. Differentiating this, we'll get dy by dx is equals to 2x minus, so this will be 3 upon 2 multiplied by 10 upon 3. So when we multiply 3 upon 2 by 10 upon 3, 3 will cancel out. So this will become 5. So this will be minus 5x to the power, and decreasing 3 upon 2 by 1, that will become 1 upon 2 plus 5x. So that will become a plus 5. Now equating it equals to 2, we'll get 2x minus 5x to the power half plus 5 is equals to 2. Bringing 2 on the right hand side, we'll get 2x minus 5x to the power half plus 5 minus 2, which is equals to 3. Now we can solve this equation by taking a substitution. So we can write y is equals to x to the power half. Now as y is x to the power half, so x will be equals to y squared. So we can write the equation as 2y squared minus 5y plus 3. So we can now find the values of y, and then using the substitution, we can find the value of x. So factorizing this, we'll get 2y squared minus 3y minus 2y plus 3 equals to 0. Taking y common, this will become 2y minus 3, and taking 1 common over here, we'll get 2y minus 3 equals to 0. Simplifying, we'll get y minus 1 and 2y minus 3 equals to 0. So the value of y will be y equals to 1 and y equals to positive 3 upon 2. Now once we have the values of y, we can find the value of x as x is equals to y squared. So over here, when the value of y is 1, so this will be x is equals to 1 whole squared. So x will be equals to 1. And the other value of y is 3 upon 2. So this will become 3 upon 2 whole squared. So the second value of x will be x equals to positive 9 upon 4.